Hey, Sci2 kiddos. I'm going to use these slides to quickly review Charles' law. I know it's weird, you're like, then why is Boyle's law on the screen? But just as a reminder, we have now covered Boyle's law. He was looking at the relationship between pressure and volume, and he found that those are inversely related. Where pressure goes up, volume goes down, or volume goes up, pressure goes down, or vice versa. That is the only inverse relationship. All other ones are directly proportional. Charles' law is looking at the relationship between volume and temperature. And again, what the law states is that volume is directly proportional to temperature. In other words, if volume is to go up, then temperature will go up. Or again, if temperature goes down, then volume of a gas will go down. Again, this is always describing a gas. Charles's law is assuming a constant pressure and constant amount of moles. So notice there's no P here, right? We are assuming that pressure stays the same throughout, as does the amount of gas. Again, don't need to worry about memorizing it. But here's the equation. V1 over T1 is equal to V2 over T2. Just like before, volume just has to match in its units, but please note temperature must be in Kelvin. Never use degrees Celsius, never use degrees Fahrenheit. It won't work. The math is based on Kelvin. It must be in Kelvin for temperature. So let's do a practice problem here. If you have 45 liters of helium in a balloon at 25 degrees Celsius, and increase the temperature of the balloon to 55 degrees Celsius, what is the new volume? So again, I know that's my V1, this is my T1, this is my T2, and my unknown volume, I'm trying to find V2. Now notice, they're kind of tricking us here. They're giving us the temperatures in degrees Celsius. You cannot use Celsius. You have to use Kelvin, so we just add 273, right? You always just are doing plus 273. That will give you the Kelvin. What you should end up with is 298 Kelvin here and 328 Kelvin for this. So now just plugging into our equation for Charles' law, remember that is P1 over T1, or sorry, V1 over T1. V1 over T1 is equal to V2 over T2. So that's going to be 45 liters divided by 298 Kelvin. That's my V1 and my T1. And I know that's going to be equal to my unknown V2 over 328 Kelvin. Now, if you're not sure how to solve fractions like this, just remember to cross multiply. That's the key step to understand, right? We know that this times this is equal to this times this. So in other words, I can rewrite the equation as 298 Kelvin times my unknown V2. So again, that's from that, cross multiplying, is equal to 45 liters times 328 Kelvin. Cross multiplying that. So now that I have them linearly, I know that I just need to divide both sides by 298 Kelvin. Those will cancel out. We've got 298 Kelvin here. And so I just need to solve that. 45 liters times 328 Kelvin. Divide that by 298 Kelvin. Notice the Kelvins will cancel, and I'm left with just liters. And you should get that V2 is equal to about 50 liters. All right. Go ahead and give this second example a try using those same methods. Okay, hope you remembered to convert to degrees Celsius, or convert degrees Celsius to Kelvin. All right, you can see the answer here. Again, you should have had your converted your temperatures to Kelvin, set them up, cross multiply, and your second volume, V2 is what you're trying to find, should have been about 5.1 liters. In the real world, we'll see a video of this, but often you'll see balloons will shrink in colder weather. If you were outside and below freezing temperatures, balloons actually kind of shrivel up a little bit, and that's because the gas on the inside is, right, if the temperature decreased, then the volume of the gas decreased, Whereas if you go into a warm room or warm temperature, then the temperature increased, and therefore the volume of the balloon will also increase and stretch that rubber. All right, hope that was helpful.